Today, in continuation of our previous video, we are starting with question 4 and 6, sub question 6. Here you have to prove the identity. So here you see, so sine, if you have to go to sec, what we will do, we have to divide it by, suppose 1 upon cos we will write. So we will dividing it with cos. Divide with cos. Okay. So 1 will become 1 upon cos. 1 upon cos, it will come sec. Plus sine upon cos, it will become tan your. 1 upon cos minus sine upon cos. Okay. So here one upon cos is equal to now sec, and sine upon cos, it is equal to your tan. And here one again sec A, of course A or theta you have to write everywhere. Okay, A or theta everywhere you have to write. Sec A minus tan A and whole square it will remain. Okay, this will come. Now we have to make it short, so better we will rationalize it. Rationalize means we will multiply it, rationalize. We will multiply it with sec plus tan. Okay, multiply. This is known as the rationalization. Rationalize. So what will happen? It will multiply sec plus tan. So it will multiply upper portion also. Sec plus tan multiplied by sec plus tan, and lower side sec minus tan and sec plus tan. So what is here? Sec plus tan, double is it is, so sec plus tan square we can write, and here sec minus tan, sec minus 10 and sec plus 10, a square minus b square we can use. So here we will use a square minus b square for lower side. So it will become sec square minus tan square. Okay, so it has come to this stage. So here sec square minus tan square is equal to 1. We have one identity we have, that is 1 plus tan square is equal to sec square, or we can write 1 equal to sec square minus tan square. This is another identity we have. So sec minus tan square we can write 1. Upper portion will remain like this, sec plus tan square, and lower portion in place of this we can use 1. So 1 we can, and whole root is there. So now again root is here. So 1 will under root, it will go out. Sec tan and sec tan root, if you will remove, it will remain as sec plus tan. Okay. Sec plus 10 upon 1 equal to sec plus 10, and it is proved. Okay, by this way we can prove this is equal to this one. Okay, now we will go to question number 7. So here you say we have power of 3 and our formula are all in identities are in square. So what we will do, we will first make it in square. So for that, common we will take out. So common we are taking out. Here common, it is common. Common we have taken out. Sine will come out here, 1 will remain, and 2 sine square it will become. Okay, and here we will common cos we will take out. Cos we will take out. What will remain? 2 cos square minus 1 will remain. This side is your RHS. So LHS we are proving. LHS first we will prove and see whether tan is coming or not coming. So after this, what we can do? Sine square. Sine square is 1 minus cos. So here we will make some changes. So it is sine. 1 will remain as it is. Let it remain. And 2 we will take out of it. Multiply sine is there. So here we can write sine square. Okay. Upon cos 2 cos square minus 1. Here sine square is there, so later on we will replace it. Sine square is there, sine square is there, we will replace it with it. Sine 1 minus 2, and here now we are replacing 1 minus cos square. So now bracket we will open. First we will multiply, then only this bracket can be solved. So sine 1 minus, it will open, it will become plus sign will become minus sign, minus 2, and this minus sign will make it plus sign, 2 cos square. Okay, upon cos 2 cos square minus 1 it will come. So if you solve it, it will become minus sine minus sine, and it will become your what will become 2 minus 1, so it will minus 1 plus 2 cos square, it will remain, and here cos 2 cos square minus 1. You see minus 1 minus 1 is common, 2 cos plus 2 cos plus. So this you can cut. What is remaining with you? With you it is remaining sine upon cos. Sine upon cos is equal to 10. And that you wanted to prove, so it is proved. Okay, in this way you can prove it. 7th. Now we will go to your 8th question. Okay, I will grab and write the 8th question. Now, question 4, sub question 8. So, it is written and you have to prove this one. So, we will use a plus b whole square that we are using. We will use identity a plus b whole square. This identity we are using and expanding it. So, what will happen? Sine square plus cosec square. Of course, a everywhere you have to write. If I forget, you just remember. Plus 2ab, 2 sine cos. Plus here also we will apply this cos square plus sec square plus 2 cos sec. Cos and sec. Okay. Now we will sine cos. Here 1 upon cos, if we can write sine, we can write 1 upon cos, we can write write 1 upon sine, so that we can cut it. Sine square plus cosec square plus 2 sine into here cosec we are changing 1 upon sine, so that we can cut it, plus cos square plus sec square plus 2. Here also we are making a change to cos and Sec we can write it. Sec is opposite of cos. So into 1 upon cos. Okay, we can write it. Now this and this we can cut. This and this we can cut. Here sine plus cosec square and cos plus sec square is coming. So now cosec square, we have identities are there where cosec is coming. Our identities are 1. So we have this identity with us. So in place of cosec square, we can write cot square. This we can write. So we will write here cot square plus 1. Cot square plus 1 we can write. Plus 2 into 1 it will become 2. Plus cos square. Cos square plus, in place of sec we can write 1 plus tan square. 1 plus tan square plus here 2. Because we have to reach 7, that's why this number we are creating. Again, sine square plus cos square, 1 place plus cot square plus tan square. All this we have made 1 place. 1 and 2, 3, 3 and 4, 4 or 2, 6 plus 6 it will become. And sine plus cos square, we have another formula. Sine square plus cos square equal to 1. So here we can replace 1 plus cot square plus tan square plus 6. So in place of sine and cos, we have used 1. Now 6 will become your 7. So cot square plus tan square plus 7. Now tan square has come, cot square has come. So it is your proved. Because it has reached up to here. Okay. So by 8th is over. Now we will go to question number 9. We will go to question number 9. So here this is there. Cosec we can write it 1 upon sine. Because we have sine, then cos and tan. And its opposite are cosec, sec and cot. These are the opposites. So this you have to keep in mind. So cosec we can write it 1 upon sine. 1 upon sine minus sine A. Nothing is there, so 1 is understood, but we don't write. And here it will be sec opposite of cos, 1 upon cos minus cos A. Okay. So here you take the LCM in first this bracket. LCM is sine. So sine will divide it, sine and sine will divide it, and it will become 1 again, minus. Now here nothing is there, so it will divide it and sine will come. Sine and sine will become here sine square. Okay. Similarly here cos is LCM, cos is your LCM, so this is your LCM. So what will come? 1 will remain, and here it will become cos square. Okay. So now what we can do, we have to multiply. Okay. We have one identity there, sine square plus cos square is equal to 1. So here if you write sine square minus 1, it will be equal to cos square. So here 1 minus sine square. Okay, one minute. You can write it cos square is equal to 1 minus sine square. 1 minus sine square. So we can write cos square. Cos square upon sine. multiplied by here 1 minus cos square we want 1 minus cos, so it will again become your now this I am removing. So suppose we want 1 minus cos, so this will go to this side 1 upon cos square. So what will remain here? Here sine will remain, sine square equal to 1 minus cos. So here we can write sine square upon cos we can write. Now this cos, if you will cut it, what will remain? Cos will remain. This sine, if you will cut it, sine will remain, because it is sine into sine. Square is there, so means it is sine into sine. So what is remaining? Cos into sine is remaining. Cos sine A. This is remaining in your LHS. Now, in the book also instructions are there, because it has not reached up to this stage. So what we will do? We will solve it separately again. We will solve this side also, here. So equal to 1 is there, 10 we can write, 10 we can write. Another is 10 is equal to sine upon cos, and cot is equal to cos upon sine. Okay, so here 10a we can write sine upon cos a plus cot we can write cos upon sine a. Of course a is there. Okay, now you take the LCM of this one. So our LCM is cos sine. This is your LCM. Cos will divide it, sine will come, and it will become sine square, plus it will divide it and cos will come, it will make it cos square. Upper portion 1 will remain. Upper portion 1 is there, so that one will remain here. Okay, now I am removing. So this we can take to upper side, 1 into cos sine upon sine square plus cos square. Because it is in divide, it will go upside and make it multiply. Okay, sine square and plus cos square. Now sine square cos square is the identity of 1. Sine square plus cos square equal to 1. So we can write cos, multiplying it cos and sine upon 1 we can write. So this one will divide it, and what will remain? Cos and sine. Here also cos and sine was remaining. So this is your RHS. As LHS equal to RHS, so proved. Okay, this is proved. Now question number 10 we are going to do. So here we can make it as a 10, so that later on we can cut. So what we will do? 1 plus 10 square upon 1 plus 1 upon 10 also we can write for cot. Okay, so here 10 square is LCM. 1 plus 10 square, it will upper side. Lower side you take LCM 10 square as LCM. So this 10 square will make this as a 10 square, and plus 1 will remain like this. So later on this 10 we will take to upper side. 1 plus 10 square into 10 square upon, this is in one bracket, 10 square plus 1. Here you see 1 is positive, 10 is positive, 10 is. So this we can cut. What is remaining here? 10 square. So 10 square. This is your LHS. Okay. Now we will solve the right hand side. RHS we will solve because directly we could not reach, so we will solve it and try that whether this is coming or not coming. So here again cot is there, cot is reverse of tan. So we can write it like this: 1 minus 10 upon 1 minus 1 upon 10. We can write. Okay. So 10 we are taking as LCM. 1 minus 10. LCM is 10. LCM is 10. So LCM will make it 10. 10 minus 1. So now 1 minus 10 is in one bracket, and this 10 you can take upward in the multiply position in 10 upon 10 minus 1. Okay. So here this sign is not same. So what we can do? We can do one thing, into 10, and here you take the minus sign as a out. Common, it is common we are taking out. Common, sign change, we are doing sign change. Sign changed. Sign change by common. So if you take out minus from here, from this portion, from here, denominator. So what will, this will become minus 1. Then only plus will come here, no, minus 1, and this will become plus 10. Sign will change. Okay. Now, minus 1, we have to change this one. 10 minus 1 we have to change. So, 10 will become minus 10. And minus will become plus 1. It will become 1. Now, 10 is minus and 1 is in plus. We can cut it. What will remain? Upper side 10 will remain, and lower side minus 1 will remain. Okay, minus 1, because if you cut 1 and 1 will remain here. 1 and 1 will remain here. So, and this your whole square is also there. So, so this whole square will remain. Okay. This whole square will remain. Here also whole square will remain. Here also whole square will remain. So what will happen? It will make 10 as a 10 square. 10 square, and minus 1 will be multiplied by minus 1. So 10 square upon plus 1 it will become. So now nothing divide, so it will come as a 10 square. So this is your RHS. So LHS and RHS both are equal. Okay, both are 10 is here also and 10 is here also. Both are equal. RHS, LHS equal to RHS. So it is proved. So it is proved this is equal. This is okay. Now with this this chapter is over. Thanks for watching our videos. Please share with your friends also, so that they can subscribe and watch our videos and get the benefit also. We will be uploading further more videos of this type. Thank you.